find an equation of the sphere that passes through the point 4, 3, negative 1 and has center 3, 8, 1. All right, well, we're going to be then looking at a sphere with a center of 3, 8, 1. Let me just draw a quick picture of this sphere. I'm not going to try and put it in the coordinate axes here, but let's suppose this is our center here at 3, 8, 1, and we know that it passes through the point of 4, 3, negative 1. And so if we're able to find then the distance from the center to that point, that's going to be equal to the radius. And that's what we need to find the equation of the sphere. We need the center, which we have at 3, 8, 1, but we also need the radius, which again we can find by finding the distance from the center to that point that is on the sphere. So the radius r is equal to, let's say it this way, that the radius is going to be the distance from our center point of 3, 8, 1 to that point that's on our sphere of 4, 3, negative 1. And so r is going to be, using the distance formula for 3 dimensions, the square root of the difference of the x values. The difference between 3 and 4 is 1. We square that amount. Plus the difference of the y values squared. The difference between 8 and 3 is 5, so we square that amount. Plus the difference of the z values squared. The difference between 1 and negative 1 is 2. So we square that amount. We get the square root of 1 plus 25 plus 4. That, I believe, is the square root of 30. And so the equation of our sphere, then, is going to be x minus the x-coordinate of our center, which is 3, that quantity squared, plus y minus the y-coordinate of our center, which is 8, that quantity squared, plus z minus the z-coordinate of our center, which is 1, that quantity squared. That has to equal the square root of 30 squared. And of course, we could write that then as x minus 3 squared plus y minus 8 squared plus z minus 1 squared. And of course, the square root of 30 squared, that is 30. So there is the equation of the sphere.